So, I'll be talking about Bremsstrahlung radiation today, but before that, a little bit of basics. So, we know that this is the X ray tube where electrons, which are heated up from the filament, are generated here. They hit the target over here, tungsten target, and our X ray are being produced here. Now, what is exactly happening at this target? Um, coming to our target, so many effects which happens here, right? So electrons, some of the electrons go near the nucleus. In a sense, it's not hitting the electrons over here, outer or the inner orbit electrons. They're going near the nucleus, as it's a negative one and nucleus is positive, so it's being attracted towards the nucleus. And while it is traversing, like Bremsstrahlung radiation is also called as braking radiation, so it is like applying a brake over here. And then when it's near the nucleus, a photon is being released. It loses a little bit of energy as photon. This is Bremsstrahlung X-rays or radiation. And the rest of the electron with a lesser energy is being released here. Or like the electron completely loses its energy here, and a equal amount of energy of a photon is being produced, and this is a Bremsstrahlung radiation. And most of the electrons which are produced undergo Bremsstrahlung radiation, as so many, it can hit the atoms. So many atoms will be there, tungsten atoms will be there, so it can hit the tungsten atom from various angles. So now this is at a different angle, so the photon energy, the Bremsstrahlung energy which is being produced, will also differ. Now coming to characteristic radiation. So characteristic radiation is when the electron hits the inner orbit, and then the inner orbit electron is being ejected here, and then this is being filled by the outer orbit electron. So outer orbit electron, which is filling the inner orbit, it will release. So we know the differences between the energy between the K shell and the L shell, right? So the difference will be the binding energy between these two. So when this electron falls from here to here, it lose some of its energy. So minus the K L and L shell and the K shell, whatever energy is being released is released as characteristic radiation. Now this characteristic radiation is very specific to the atom which it is. So tungsten atom, as the heavier atom it becomes, the characteristic radiation will differ, and it is characteristic to that particular, specific to that particular atom. So characteristic radiations are usually monoenergetic, and Bremsstrahlung, because it can act in different angle and everything, it's a heterogeneous energies. And most of the effects that is happening is, most of the X-rays which are being produced are Bremsstrahlung, and lesser amount of characteristic X-rays are being produced. And the same information in a better diagram. So it's the electron is going near to the nucleus and it's losing its energy, and the electron with a lesser energy is being produced. This is called Bremsstrahlung radiation. Now, what is characteristic radiation? As I just said, this is a primary electron which is hitting the inner orbit electron, and this electron is being ejected, and here the primary electron with a lesser, like after collision, is being released. Now this void is being created. This is filled either by L or M K shell, right? So if from L it is if it's falling here, so it is like the characteristic radiation of that shell, and if it's falling from here, it will be the characteristic radiation of this shell. But it will, we know, we can calculate the energies because difference will be the difference in the binding energies of this. So a little bit of how it's being produced. So most of the radiation, most of the Bremsstrahlung radiation, you can start from the different energy. So as I said, like as it goes from the in different angles, the energies will differ. So this will be the photon energy on the x-axis and the relative number of photons on the y-axis. Now the photon energy, the yellow one here, what you see, or the Bremsstrahlung radiations, and the peak here which you see is the characteristic radiation. So here Bremsstrahlung radiation, you can see there are so many from 0 to 50, there are various amount of number of photons being released. Those are Bremsstrahlung radiation. And even here, now these are characteristic radiation is characteristic to the particular shell, so it will be like monoenergetic. So at a particular energy itself, you can see the characteristic radiation. Now just a basic difference between um, photon and Bremsstrahlung and characteristic. As I said, Bremsstrahlung is heterogeneous, like many energies you can see, and characteristic is monoenergetic. And Bremsstrahlung is also called as braking radiation or white radiation. And characteristic radiation in diagnostic radiology, 30% of the X-rays which are being produced in the target are characteristic, and the rest is Bremsstrahlung. And therapeutic radiology, that is radiotherapy, only 3% of them are characteristic, the rest of them are Bremsstrahlung. And both of them depend as square to the atomic number. As the atomic number increases, their probability of Bremsstrahlung and characteristic radiation is related to the square of the atomic number.